So myself, my name is Dan the Rocket Man. This guy over here is also Dan the Rocket Man. And you are Malcolm. Also it doesn't rhyme as well with Rocket Man, but that's okay. And we're going to help out. We've got, of course, our helpers out here, okay? And it'll be really hard for me to go around and remember all you guys' names, so I might just ask you later on what your name is, okay? So I want to start off by doing a little review. I heard that one of your past classes was about, maybe it was the four forces of flight. You guys remember that? Do you guys remember what the four forces of flight are? Yeah. Okay, raise your hand, let me know. Give me one of the four forces of flight. Right there, number one. Yeah, what do you got?
Thrust.
Thrust. All right, I like it. Thrust. Okay, we'll talk about these in a second. What do we got? Another one. What's another one? Not thrust, but? Gravity? Ooh, okay, that's close. Let's call it. Actually, that's good. I like gravity. We're going to call it weight, right? W-E-I-T.
Can't erase.
Okay, and then I'm going to put in parentheses gravity, because you're right, that's why. Although it's getting into my rocket area here, I better make sure I'm not going to mark and I'll go over the line. Okay, what else do we have? Raise your hand, please. There's two more left. We've got thrust. Okay, we've got weight, or gravity. What else? Drag. Oh man, that guy was right. What was your name? All right, he knows what he's talking about here. Drag. Okay, we got one more. Airplanes, what makes them fly?
Wings.
Wings, and what do wings produce? What's it called? That makes you go up.
Lift.
Lift. Excellent. Excellent. Helped you out on that one. That was good. So I was going to review these for you, and we're going to apply them to rockets now instead of the airplanes. Sound like a good plan? Because we're going to make rockets here, and all these four forces, we're going to see them all in effect. We're actually going to see them out there in the parking lot working. So I'm going to draw myself. I'm not a very good artist here, but I'm going to try to draw a rocket of some sort here. See if I can do this. A little nozzle here. Do I have the red marker? I don't. I'm just going to have to use a little black plane here and some smoke. Right? And then we got to have some fins over here. Right? Look at that big fins, right? There's another one here. You can see the side of it. And then there's a guy up here in this little capsule. Okay, he's up here. Okay, so I want some help, okay? Which way, or which direction? Remember, our forces were directions, right? Right? There was like arrows pointing. So which one points upward? That way. Thrust. Who said thrust? Excellent. Excellent work. So I'm going to put an arrow over to the side of it. Or maybe I'll put it right in the middle, right? This is good. You good? We're going to talk about this in a second. Okay. So thrust goes up, right? I'm going to call that T for thrust. All right. What else do we have? Give me what points down in this case? Gravity. Excellent. Oh man, that guy's on top of things here. What was your name, buddy? All right, Joshua. Excellent work. Gravity. I'm going to put G for that one. Also weight, right? Gravity causes us to weigh, right? Okay. What about? There's another one pointing this way because the rocket's moving up. What's opposing us when we're going through the air? What slows us down? I heard somebody over here say drag, right? So that actually points down too, right? So drag points down as well. On an airplane, drag points in a different direction, doesn't it? You guys remember an airplane? Let's see if I can draw a little airplane here. Maybe I'll do this. A little cockpit there, a little fin. That's like a little cartoon airplane with some wings. A little landing gear, right? Right, so on this one, drag points this way, right? Drag points this way here. And what's that one here? Lift. Where do you think lift goes on this one? Which direction do you think it goes? Up, right? Because the rocket goes up. All right, good. So look at, this is a little different than how an airplane. So with this, we got W down here. We'll call it G, weight. What's the one that pushes forward in an airplane? Thrust. Okay, this was lift, we said, and this was drag, right? This one's drag here, and this one was lift, right? You see the difference between the airplane and the rocket? Well, these are one, lift points up here, but thrust points that way, and this one, lift and thrust are in the same direction, right? So in a rocket, all the lift is produced by the thrust. They're one and the same, right? So this rocket actually is a rocket I built from scratch and I launched. And we put a motor in here. This is the size of the motor that we launched. You guys ever launched a model rocket? Like those Estes model rockets you buy at the store? How many people? 1, 2, 3? Oh, it's a lot of fun. Okay, as you get older, maybe that'd be a good Christmas present somewhere in the future. Birthday present? I don't know. I learned a lot about rockets just from playing around when I was a kid, about your guys' age, right? How old are you guys? Like, anybody know? 9, 10, 8, 12. Okay, perfect time, guys, to get involved with learning about rockets because
He's 26 years old.
it's fun. It's fun, number one, and number two, you're learning a lot. So when I played around with rockets when I was a kid, it led to what I do today, which is basically I work as an aerospace engineer, and I've worked on rockets, helicopters, tilt rotor airplanes, and now I'm working on jet airplanes. And that's where Dan works too. And Malcolm, do you work at Boeing as well?
No, I work at Microsoft.
He works at Microsoft, so he makes the computer games, you guys. Right? Maybe the computer game is a flight simulator or a rocket simulator. Okay, so those are the four forces that are going to work on a rocket. So what do you think the engine does? What is that? Which one does the engine do? It does both of these, right? Thrust and lift. So the exhaust gases come shooting out the bottom. That's what I try to draw down here. And as the exhaust gas goes shooting down, what happens to the rocket? It goes up, right? It goes in the opposite direction. Same thing with our water rocket. Let me show you what we're going to make here today. Dan and I made this in the garage. We've got tennis balls, some duct tape, some fins. We fill this about a third of the way full of water. We pressurize it with air. What do you think comes shooting out the bottom? Water. And what does the rocket do? Goes shooting up, right? So we're going to shoot water down and the rocket goes shooting up. So that's what's causing our thrust, that equal and opposite force. What about what's slowing us down? Why wouldn't it go up to space and go out to forever? What's slowing it down? Drag. That's slowing it down. There's one other thing too.
Weight.
The weight, right? Gravity. Okay, excellent. So those two things are pulling the rocket back down to the ground. What would happen if I used, and I made a rocket out of feathers? Would it be heavier? Lighter, right? So the structure that you make a rocket out of is really important. If you have a lightweight rocket, you don't need nearly as much thrust to go up, right? If you want to go up into space, you need a pretty light structure and have all this fuel, so it can keep burning and shooting, you get a lot of thrust out of it. I want to pass this around, guys. These rockets I made on my own when I was in college, and I went out and I launched these. This rocket here went to about 2,500 feet, which is about a half a mile up in the sky, so 2,500 feet. It's got a little parachute, it's got this cord, and it shoots this little thing out with a little charge. So a little explosion happens down here at the bottom where the engine is. Boom! When it gets to the top of its apogee, it shoots this parachute out and comes sailing down to the ground under the parachute. Pretty cool, huh? Okay. We can't launch it because it goes to half a mile up. It'd be in the other county, you know? It's too far away. You actually have to have FAA clearance to launch that rocket. So this is basically the same exact stuff you would go buy at your local hobby shop, an Estes rocket. It just happens to be a much bigger motor and a much bigger rocket. So you start out small and you work your way up to something big. Here's another one I made. This is a bigger rocket, right? This one is heavier. It used the same motor. So do you think it went higher or lower?
Lower.
Lower, exactly. So this one only went to about almost 2,000 feet. Okay, now it went to 2,500 because it's lighter. And this one even has a bigger or smaller parachute. Yeah, much bigger parachute. How if I can get this out of here? Let's see what we got in here. Oh, there it is. Yep. Much bigger parachute. So this fluffs up right, brings the rocket down safely. Just like you would with the hobby rockets you get at the store. What I want to get at really quick before we start building our rockets, because you guys are going to construct the rockets, right? Construction and making it lightweight is very important, right? So this is a fiberglass tube I made, and I made this out of what basically it looks a lot like your shirt cloth. It's flexible. It's right here. It's called fiberglass, okay? And you put a glue in it called epoxy, and when the glue cures and hardens, this is what it ends up as. Pretty neat, huh? So I'm going to pass this around. There's another material a lot like fiberglass called carbon fiber. And a lot of jet aircraft. So our Boeing airplanes, a lot of them are not the whole airplane, but a lot of the airplanes is made out of this carbon fiber. It's also made out of little fiberglass. Rockets are made out of this. Missiles, and jet fighters like the F-16 or the F-22 Raptor, you guys know what those are? They're made out of carbon fiber as well. So I'm going to pass this around. This is the carbon fiber after I put the glue in it and it's hardened. Careful, the edges I've sanded, but they could be a little bit sharp. Okay, the black one here is going to go with it. This is exactly the same fiber as this. This is before it got the glue. Okay, so I'm going to pass that around. You guys pass that out. Here's some fiberglass. That's what went with this. We can set this at one at each table and people can look at it and then pass it to the next table carefully. So So there's the fiberglass. You can see that's what it looked like before, that's what it looked like after. And this is Kevlar. This is also a fabric which you can harden and it turns into something just like those two, right? Kevlar is also what they use in bulletproof vests. Okay? And this is kind of cool. This is a mix. It's a mix of carbon fiber and Kevlar. So I'm just going to pass these around. I'll give this to your guys' table here. Okay, one last thing I want to say before I pass it on. What do you think these are for? These big things right here. So what are they called? Fins. And what do you think they do for this? Why do I put them on the rocket? So it goes what? I didn't hear it. Just say it a little louder. I'm sorry.